Hello, IB 11s. Today we will look at the first lesson in Chapter 4, Logarithms in Base 10. First, let's look at different powers of 10 first. I hope that you guys can be very proficient at changing all those values to powers of 10 without any troubles. The first one, 10,000. So this one is 10 to the power of 4. 1,000. This one is 10 cubed. 100. This one is 10 squared. This one, 10, means it's 10 to the power of 1. And we all know 1 means 10 to the power of 0. For 0.1, this one is the same as 1 over 10. If I use a power of 10 to represent 1 over 10, we need to use the negative exponent. This one is 10 to the power of -1. Likewise, 0.01 is the same as 1 over 100. If we use a power of 10 to represent 1 over 100, this is 10 to the power of -2. 0.001 is 1 over 1,000. The power of 10 is 10 to the power of -3. This is the cube root of 10. If I convert this one to a power of 10, this one is 10 to the power of 1/3. We have already reviewed all the exponent laws in Unit 3. Hope that you guys still remember. A to the power of 1 over n is the same as the nth root of A. So here, this one is the square root of 10, which means the index here is 2. So if I convert this one to a power of 10, this one is 10 to the power of 1/2. So this square root of 10 goes to the bottom. So it will be the same as 1 over 10 to the power of 1/2. So we all know we can convert this one to the negative exponent if we want a single power. So this one is the same as 10 to the power of -1/2. And this one, 1 over the cube root of 10, is 10 to the power of -1/3. So similarly, this one is 10 to the power of -1/4. I hope that you guys can ask yourself if you have still troubles in converting all those values into the power of 10. So right now, based on the powers of 10, let's say if y equals f of x is 10 to the power of x, we need to find its inverse and then draw the graph of its inverse. We have already known how to find the inverse of the function. There are usually 2 steps. Step 1, we interchange x and y. So in this original function, y equals 10 to the power of x, we switch around x and y. We will get x equals 10 to the power of y. Then the second step is solve for y. When we want to solve for y here, we find that we will have the trouble in finding the y. So how can we find y? But before we find the y in terms of x, let's look at the graphs of the original function and its inverse first. We all can graph this original function already. this original function, let's say I want to use the red color to graph this original function. So you can use some points to help you. For example, when x is 0, y is 1. When x is 1, y is 10. Okay, it's maybe beyond the grids, but that's fine. It's just one little square above, okay, the topest one. So you just estimate the position. But you guys also know the base in this exponential function is larger than 1. So this exponential function is an increasing model. So that's how I can graph the original function. So that's y equals 10 to the power of x. If I want to graph its inverse, I know, okay, I can graph a line which is y equals x line. Let's graph this line. So this is y equals x line. We have already learned this one in Unit 2 already. If two functions which are inverse to each other are reflected over the line y equals x, so its inverse should be a reflection image in the line y equals x. So we know the original graph passed through 0, 1, and this special point is 110. So my inverse graph, let's use the blue one, should pass through 1, 0. You can just switch around the x coordinate and the y coordinate for every point. So the second special point will be 10, 1. Okay, so here we go. The graph, which is the refraction image over the line y equals x, is this blue one. Okay, so we can graph its inverse, and we also know the inverse of y equals 10 to the power of x pass through 1, 0, 10, 1. And then we even can find more points. The original function also passes through to 100, 3, 1000. The inverse function, although I don't know how to express the inverse one yet, however, I will know the inverse function must pass through 1, 0, 10, 1, 100, 2, 1000, 3, and etc. And we also can know the original function has horizontal asymptote, which is y equals 0. And this y also becomes x. So we will know the inverse function should have a vertical asymptote, which is x equals 0. Okay, so right now, we need to look at how we can find the y value here. In order to find this y, so we have one mathematician. Okay, we will introduce this mathematician later on. He invented a symbol. This symbol is a log symbol, which is log. And my base is 10, which is the same as the base in the exponential function. And then I say this one is x and this is y. So with this new invention, this new symbol logarithm, I can solve for y, which means I can bring this y down, and this y is log x in the base of 10. Okay, so right now we look at the definition for the inverse function. So based on this one, we know this one is the inverse of y equals 10 to the power of x. And we switch around x and y. So right now, just because people got stuck in solving for y, so we make a new definition for the variable y. So the definition for the variable y as follows. So this y is defined as log. Here is the base 10. We just put down as a kind of sub for the log symbol. And this one is x. You need to remember, this x is the y in the original function. And this y is the x in the original function. But in the logarithm expression, this x is called argument. And this 10 is still called the base of the logarithm. And then how to call y? Because the y in the inverse, previously it was in the exponent. Right now we brought this y down. We call this y logarithm. Logarithm is a Latin word. The meaning in Latin language is the inverse of the exponential operation. So this one is read y is the logarithm in base 10 of x. Okay, there is a long way to express this one. So some teachers may call y is the logarithm of x to the base 10. For me, later on, I prefer to call log x base 10, which is way shorter than this expression. Okay, so here you guys need to always remember a logarithm actually is just another way to represent the exponent. It's mainly because in this inverse, people had trouble to bring this y down. So this reason we invented a symbol which is called a logarithm in order to bring this y down. So a logarithm is an exponent. So this y is exactly the same as this y in this inverse. You guys need to remember x equals 10 to the power y is the inverse of this y equals 10 to the power of x already. So which means x equals 10 to the power y and y equals log of 10x are mathematically identical. They're exactly the same. So this one is the same as this one. Or we can say this one is exactly the same as this one. So y, this logarithm, is an exponent in the exponential form.